Today in this video we will study about the physical, mechanical and chemical properties of the reinforced steel. Mechanical property, we study how a material will respond to the load applied to it or force applied to it. So let us start with the mechanical properties of metals. Rebar, mechanical properties of metals. They are strength. This is the property of metal, that how much a metal can withstand load till it failures. In this we study about yield strength and ultimate strength. Toughness. This is the property of metal, how much energy it will absorb before it fails. Ductility is the property of material, how much deformation material can be done before it fails. Like if a copper, we can draw a very big string of it. Elasticity, the property of metal to regain its original shape and size. Plasticity, permanent deformation under application of load. The property of metal to get it permanent deform under certain specific load. Beyond that, it will not regain its original shape and size. Hardness, resistance to the scratch or identification. A property of metal, how much it is tough so that it cannot be scratched. Like diamond is a most very hard material. Creep, long term failure of a property of long term failure. Like when environmental condition changes, a metal gets fail under temperature on the constant same load itself. Creep, malleability, property of material to go under deformation. Like if we make from the billet to a plate. So this is a property. Like from gold we make, and from silver also we make foil of it. Fatigue, then brittleness, then stiffness. Etc. is a property of metal which we determine for the different purposes. In case of reinforced steel, we determine strength, toughness, ductility, elasticity, and plasticity of importance to a civil engineer who is working in the field with the reinforced steel. Physical properties of metal. We determine the physical properties of metal, like density, what is Young modulus, what is coefficient of thermal expansion, what is Poisson's ratio, what is density. What is modulus of elasticity? Elasticity. What is modulus of elasticity? What is coefficient of thermal expansion? What is Poisson's ratio? As per IS 800, IS 800, this is the property required for the structural steel. Then chemical composition of metal, of reinforced material, post steel. In this, we carry out chemical test to know how much percentage of carbon content is there, how much percentage of sulfur is there, how much percentage of phosphorus is there, and how much combined sulfur and phosphorus is there in the metal to understand the stability of metal for the reinforced steel. So we carry out chemical test for carbon, for sulfur, for phosphorus, phosphorus, sulfur plus phosphorus. It is as per IS 228. We carry out the test uh, to know the carbon content, sulfur, phosphorus, sulfur plus phosphorus. This is the maximum. This concentration will be maximum in maximum proportion in any metal. So these chemical tests are carried out. This is stress strain graph of metal. When we apply the load, then this stress and strain graph comes after determining the force versus elongation. Then it is converted into stress and strain. A graph is drawn. We know that stress is symbol is sigma, and it is force upon A. A is area of cross section. Area of cross section of metal. Section of metal or reinforced steel. And strain is epsilon. Its symbol is epsilon, and delta L over original length. So difference in length and upon original length. So from in this limit, this is elastic zone. This is elastic zone, and in this zone, when applied load and elongation, they are proportional. Stress stress is stress proportional to strain. Follow the Hooke's law. In this zone, when metal is stressed, a tensile load is applied. After releasing the load, after removing load, it comes back to its own shape, and it goes to a yield point. After yield point, permanent deformation occurs. So second point is B. In this also material regain to its shape, and there is a upper yield point and lower yield point. We are not able to find out upper yield point because of a sudden application, a sudden change in the property. But surely between B and C, we are able to find out a small difference. So lower yield point from here, from upper a permanent, this is permanent deformation. So it is a plastic zone. This is plastic zone, and this is elastic zone. In this zone, material regains its shape, elastic zone. And then breaking stress and the failure. So this is typical stress strain graph. Stress is taken in the y-axis, strain is taken in the x-axis, and stress is taken in y-axis, and all properties are determined based upon this graph in the laboratory. We take the specimen and put into the universal testing machine, apply the load and record the readings, and after deriving the readings, we draw this graph, and after that we find out how much the yield strength of material, how much the ultimate, this is the point, this ultimate strength of the material. Corresponding to this, we find out stress. So this is ultimate stress, and this is ultimate stress, ultimate stress, and this is yield stress. For designing of any structure, these two stresses are very important. So very careful test is carried out very carefully to find out this yield stress and ultimate stress. It is also at 0.2% proof stress. So we will discuss separately what is proof stress and how it is determined, and how a parallel graph is done to find out yield stress. So elastic limit, it is where stress is proportional to strain. After deformation, within the elastic limit, material regain its shape once the load is removed. After removal of the load, removal of the load, metal, a material regains its shape, and yield point is that point after which permanent deformation occurs. Upon the application of load, beyond yield point, permanent deformation will occur. Permanent deformation will take place to the metal. It will not regain its shape and size. Ultimate stress point is the load, is the maximum load withstand by the metal. In this, we studied about elastic limit. In the elastic limit, stress is proportional to strain. Once load is removed from the material will regain its shape or size as its original. So within the elastic limit, the material is after removal of the load regains the shape and size. Yield point is that point beyond which a permanent deformation will occur and material will go under permanent deformation and in plastic zone. And ultimate stress point is the maximum load a material can carry is known as UTS, or ultimate stress point, or ultimate tensile stress. So physical property